Welcome to the deep dive. Okay, so today we're tackling a topic that's, well, it's everywhere, isn't it? Artificial intelligence. Specifically, though, we're going to pull apart two terms you often hear kind of used interchangeably, but they have really distinct roles, different impacts: generative AI and predictive AI. You've sent us some excellent source material on this, and our mission for this deep dive is basically to give you a clear, concise handle on what these AIs are, how they actually work, and maybe most importantly, where their biggest impacts are likely to land in the next, say, 10 years, especially within manufacturing. So get ready for maybe some aha moments, because this is going to be a fascinating look into the future of, well, innovation and efficiency. So let's just jump right into it. When we talk about generative AI, what's its core superpower? Like, what is it fundamentally trying to do?
Right. Well, what's truly fascinating here, I think, is that generative AI's primary goal is to create new content, stuff that just didn't exist before. Think about text, images, new product designs, code, even like designing new molecules from scratch. It's really about generating novel outputs. Now, contrast that with predictive AI. Its whole aim is different. It tries to estimate the future value of something we already know about, right?
Yeah.
Based on historical patterns, past information. So predicting next week's demand for a product, or maybe when a machine part is likely to fail, future prices, or even classifying something like a customer's potential behavior. It's about forecasting, really, making educated guesses about what's coming, not inventing.
Okay, so one creates, the other forecasts. That distinction sounds pretty fundamental, doesn't it? But what kind of digital brains or models are we talking about for each? Are they built differently?
Exactly. They're really designed for different jobs. For generative AI, you're primarily looking at, well, advanced models like diffusion models. They creatively build images or other content step by step, almost like starting from noise. Or, the widely known large language models, LLMs, that power tools like ChatGPT, the ones generating that very human-like text. On the predictive side, it's often more about powerful statistical tools, things like time series models for forecasting trends over time, or robust ensemble methods that combine many simpler models to get higher accuracy. Think about predicting stock prices or, equipment breakdowns.
And how do they actually learn? How do you teach an AI to, well, create versus teaching it to predict? What's their, training objective?
Yeah, that's key. Generative AI typically learns by trying to produce samples that seem realistic. It's almost like a master forger trying to make a perfect replica, something indistinguishable from the real thing. It often learns this from massive amounts of unlabeled data, just observing text or images, without explicitly being told this is right or this is wrong. It's just trying to figure out the underlying patterns. Predictive AI, on the other hand, it's constantly tweaking itself to minimize the gap between its prediction and the actual true outcome, which means it absolutely needs labeled training data. It has to have examples where it knows both the input and the correct output it was aiming for.
That makes sense. Okay, so one learns to imitate and invent, the other learns to get the answer right based on past examples. And that must lead to really different kinds of outputs, right? I mean, what you actually get out of them must be totally different thing.
Precisely. Generative AI gives you creative artifacts, things like a brand new design sketch for a product, or a synthetic molecule with desired properties, maybe a customized paragraph of prose. Predictive AI delivers, well, numerical or categorical forecasts, things like a specific demand quantity for next month, the probability of a machine part failing within a certain time frame, or maybe a recommended maintenance action.
And quickly, what about the data they need? You mentioned labeled versus unlabeled, but anything else? And how much can we actually see inside these models, their interpretability?
Good points. Generative AI needs huge, diverse data sets, vast collections of text, images, code, to learn the fundamental structure, the distribution of that data type. Predictive AI, it really demands high-quality, time-aligned, and crucially labeled data. You need that link between historical observations and a specific outcome. As for interpretability, well, generative AI is generally more of a black box. It's often hard to understand why it created a specific thing. Explainable AI for generative models is emerging, but it's still quite early days. Predictive AI, however, generally offers higher interpretability. You can often get insights like feature importance, basically, can tell us which inputs were most crucial for making that particular prediction. And that level of transparency is often a regulatory requirement in many industries, right? Where you absolutely need to justify decisions made by an AI.
Yeah, that transparency is a huge differentiator, especially in highly regulated sectors.
Okay.
But let's dig a bit deeper. How do these differences play out when these AIs are actually put to work? What are the mechanisms sort of under the hood that truly set them apart?
Right, their core learning methods are distinct. Generative AI is often self-supervised. It learns by predicting masked or missing parts of data. It's like trying to build an internal abstract map or grammar of the entire data set it's learning from. Think of it like learning the deep structure of a language by filling in blanks in sentences rather than just memorizing phrases. Predictive AI is typically supervised. It learns a direct mapping from its inputs, let's call them X, to the desired outputs, Y. And crucially, it often considers how things change over time, looking explicitly for those temporal patterns.
And these different learning approaches must mean they judge their own success during training quite differently. How do they know if they're doing a good job while they're learning?
It's exactly right. Generative models, during their training phase, are constantly, in a sense, trying to fool themselves or a discriminator part of the model. They use internal metrics to judge how realistic their creations are, striving to make them basically indistinguishable from real data. Predictive models, though, they're constantly trying to get closer to the truth. They measure how far off their last prediction was from the actual known outcome. Their goal is simply to minimize that error, that prediction gap.
So they measure success differently. One aims for realism, the other for accuracy against a known target. But does this fundamental difference also change how expensive they are to actually run, once they're built and deployed?
The inference cost. That's a great question. And yes, inference cost is definitely a notable difference. Generative models, especially the really large ones like big LLMs or diffusion models for images, they can be computationally quite heavy. They're creating something complex, often iteratively, from scratch. Though there are techniques now like distillation or quantization that can help lighten that load quite a bit. Predictive models are usually lighter, often using simpler statistical models or tree ensembles. But I should add, deep forecasting networks or very complex ensembles can still be resource intensive. It often dictates where you can realistically deploy them.
Right. And on that note, where would we typically find these running in the wild? Are they mostly stuck in the cloud, or can they be right there, say, on the factory floor?
It varies. Generative AI is often deployed for things like on-device generation, think image upscaling on your phone, or in powerful cloud-hosted services and APIs for content creation, or maybe on-premise GPU clusters for really intensive design work. Predictive AI tends to be much more widespread in its deployment locations. You see it in edge sensors for real-time anomaly detection right on the machine, in cloud-based forecasting services aggregating data, and even embedded directly within industrial control systems on the factory floor for immediate automated actions.
Okay, this is where it gets really interesting. Let's bring this down to earth with some concrete examples. Our source material focuses heavily on manufacturing, so how do these two different types of AI actually show up in real-world industrial settings?
Yeah, absolutely. If we connect this to the bigger picture of industry, the differences become super clear through their applications. Let's take product design. A generative AI might perform something called topology optimization. It could create these really novel, intricate, super lightweight lattice structures for, say, aerospace components. Think tools like Autodesk Generative Design. A predictive AI, doing a different job in the same area, would predict the weight, the cost, the stiffness of a candidate geometry that a human designer proposed before it's even physically built. This saves huge amounts on expensive physical prototyping.
Wow, okay. One inventing the form, the other testing its properties virtually.
Exactly. Or look at materials and chemistry. Generative AI can literally design new polymer chains or catalyst structures with specific target properties you define upfront, effectively inventing new materials that might perform better. Predictive AI, working with materials, could predict something like the glass transition temperature of a proposed polymer just from its chemical structure description, telling engineers how it will behave under different heat conditions before they synthesize it.
So in one case, we're building something entirely new, a new material maybe, and in the other, we're getting a deep understanding of its likely properties before it even exists. That seems like a powerful combination.
It absolutely is. Let's think about process planning. A generative AI could potentially write a complete CNC machine program, the instructions for a cutting machine, directly from a 3D CAD file. That automates a traditionally complex and time-consuming task for machinists. Predictive AI, in the same factory, would be focused on forecasting tool wear progression. It would predict the optimal moment to change the cutting inserts on that CNC machine, preventing costly unexpected breakdowns and ensuring consistent part quality.
Okay, that makes sense. Preventing downtime versus automating the programming. What about quality?
Right, in quality and inspection. Generative AI can generate synthetic defect images. This is brilliant for training visual inspection systems, especially when real-world defects are rare but critical to catch. It makes the AI inspection system much more robust because it's seen more examples, even if some were AI-generated. Predictive AI, using real-time sensor streams from the production line, could detect subtle anomalies and predict if a specific part is likely to fail a final quality test down the line, catching potential issues immediately, maybe even adjusting the process upstream.
That synthetic data for training? That sounds like a really smart application, especially for those rare but critical defects. Is that a common challenge in manufacturing?
Oh, absolutely. Getting enough examples of rare failure modes is a classic problem for training robust AI models. It's a perfect use case for generative methods. Okay, moving to supply chain. Generative AI could create plausible future demand scenarios, not just a single forecast, but multiple realistic what-if scenarios, helping companies prepare for various possibilities, like sudden shifts in consumer behavior or supply disruptions. Predictive AI, meanwhile, uses time series models to predict next week demand for each specific product, usually with a confidence band around the prediction. This enables much more precise, just-in-time inventory management.
Okay, planning for uncertainty versus optimizing for the most likely future.
Exactly. And for maintenance, generative AI could be used to design an optimal maintenance schedule for an entire factory floor, considering all the complex constraints, technician availability, machine uptime targets, spare part inventory, production schedules. Predictive AI in maintenance typically focuses on outputting the remaining useful life RUL for a specific critical component, like a bearing in a crucial machine. This guides proactive, condition-based maintenance fix it before it breaks. I actually remember one plant where they literally prevented a catastrophic line shutdown because a predictive AI model flagged a specific bearing issue weeks in advance. Before implementing that, they just run things until they broke, which, as you can imagine, was far, far more expensive and disruptive.
Wow, that's a tangible impact.
Definitely. And finally, let's touch on human-machine interaction. A conversational large language model, which is a type of generative AI, could write work instruction scripts on demand for an operator right there on the factory floor, perhaps adapting them to the operator's skill level or the specific task variation. An NLP classifier, which is a predictive AI, could automatically predict the correct support ticket category just from an operator's free text description of a problem, streamlining the help desk process and getting the right expert involved much faster.
It really feels like one is designing the future, inventing new things, automating creative tasks, while the other is optimizing the present and the very near future, making existing processes run better, more efficiently, more reliably. It highlights how these two types of AI tackle fundamentally different challenges, but, as you showed, with materials and design, could potentially work really well together. Which brings us to the bigger picture, really. What does all of this mean for the future, especially looking out over the next decade? How are these two AI powerhouses likely to shape the world of manufacturing and maybe beyond?
Yeah, that's the crucial question, isn't it? We need to look at the underlying forces, the drivers of their impact. Think about the data explosion. The sheer volume of unlabeled data out there, CAD libraries, endless sensor streams from machines, simulation logs. This is really the fuel for the self-supervised training that generative AI thrives on. It allows these models to learn incredibly complex patterns without explicit labels. But at the same time, that growing volume of high-frequency, often labeled sensor data coming off modern equipment is also making predictive AI forecasts significantly more accurate and reliable. More data benefits both, just in different ways.
Right, so the data flood helps both sides. What about things like rules and safety?
Good point. Regulation and safety. Generative AI's generally lower interpretability, that black box issue, means it will likely see slower adoption in truly safety-critical processes. Think aerospace components or medical device design, where understanding why a design was created is absolutely paramount for certification. Predictive AI, however, often benefits from the strong and growing demand for explainable, auditable predictions. Its ability to provide feature importance, for instance, leads to faster compliance and probably broader adoption, especially where trust and accountability are key.
So the ability to explain itself becomes a real business advantage for predictive, particularly early on. What about the economics, the ROI? Where do companies see the biggest financial returns?
Generative AI often involves higher upfront costs, bigger models, more complex training, but the potential payoff can be huge. It can dramatically reduce design cycles, cut material usage through optimization, leading to these large, transformative, sometimes one-off gains in product development. Predictive AI typically offers faster, more incremental ROI, It achieves this through the continual optimization of day-to-day operations, reducing waste, predicting maintenance needs, optimizing energy. It delivers steady, ongoing cost savings. It's more about constant efficiency improvement.
Different ROI profiles then. One big loops, the other steady gains.
Exactly. And thinking about the people needed, talent, and ecosystem. New kinds of tooling, like prompt engineering, are actually lowering the barrier for non-ML specialists, like design engineers, to start creating useful content with generative AI. That's democratizing it somewhat. For predictive AI, traditional data science skill sets, statistics, machine learning, data analysis are already more widespread in industry. Plus, many off-the-shelf software packages and platforms exist, making it generally more accessible to implement today.
And the hardware, does that favor one over the other?
Hardware trends are definitely playing a huge role for both. Powerful GPUs and increasingly specialized AI inference chips are accelerating the intensive generation tasks for generative AI, making larger models more feasible. For predictive AI, the rise of highly capable low-power edge AI chips is making real-time prediction ubiquitous. You can run sophisticated models right on the sensor, right where the data is generated, often with minimal delay, enabling faster responses.
Okay, and let's come back to that synergy point we touched on earlier. The idea that these two distinct types of AI can actually work together, how significant is that as an impact driver?
Oh, I think this is truly where the magic happens long-term. It's almost like a secret weapon for maximizing value. Generative models can produce high-quality synthetic data that can dramatically improve predictive model training, especially, as we discussed, when real-world labeled data is scarce, expensive, or hard to get. And then, flipping it around, predictive models can provide crucial constraints or feedback that guide the generative design process. For example, you could tell a generative AI, design me a bracket, but use this predictive model to ensure it will not fail under 10,000 load cycles. Or make it lightweight, but predict its manufacturing cost and keep it below X dollars. They really do complement each other beautifully, creating this powerful feedback loop for faster, smarter innovation.
That does sound powerful. A real design and validate cycle powered by AI.
Precisely. And finally, think about business model evolution. Generative AI is enabling shifts towards things like product as a service, with companies offering highly customized, on-demand items generated specifically for a customer. It changes the nature of product offerings. Predictive AI's accurate forecasts are then crucial for actually delivering on those promises reliably. You need accurate predictions for inventory, capacity planning, and logistics to meet those potentially complex, bespoke demands guaranteed by service-level agreements.
That synergy point is particularly compelling, yeah. And if we just look at the pure numbers, what's the kind of market size and adoption rate we're expecting across manufacturing for these two, say, by the end of the decade, around 2030?
The projections are quite different. By 2030, generative AI specifically within manufacturing is projected to be around $12 billion globally. It'll be primarily focused on design, R&D, materials science. Typical ROI horizons might be in the 2 to 5 year range. Predictive AI, though, is expected to be much larger in manufacturing by then, maybe around $30 billion by 2030. Its focus is heavily on operations, efficiency, maintenance, supply chain. And the ROI is generally quicker, often seen within 6 to 12 months. Adoption speed also looks starkly different in the near term. We might see maybe 10–15% adoption for generative AI tools by 2028, largely concentrated among early adopters in sectors like high-mix electronics, automotive R&D, or aerospace where design innovation is key. In contrast, predictive AI is expected to reach much broader adoption, maybe 40–50%, across many different types of manufacturing by that same year, 2028. It's seen as more foundational.
So the picture emerging is predictive AI is the broad workhorse driving efficiency across the board, and generative AI is the more focused disruptor driving innovation, especially in design.
That's a perfect summary. Precisely. Predictive AI drives tangible gains in things like overall equipment effectiveness, OEE. We're talking improvements of 5–10% and significant inventory reductions, maybe 15–20%, through applications like predictive maintenance and better demand forecasting. It hits the operational bottom line directly and consistently. Generative AI, on the other hand, is potentially transformative in areas like cutting product development time, some studies suggest by over 50%, and reducing material costs through optimized designs by over 15%. It opens up entirely new product possibilities and accelerates R&D. So yeah, generative AI is currently high impact, but likely lower penetration initially, offering breakthrough potential mainly in high-value niche sectors. Predictive AI offers high penetration, maybe moderate impact per application, but across the board, delivering steady efficiency uplift across the entire manufacturing base. In essence, predictive AI looks set to be the primary driver of short to midterm productivity gains over the next 5 years or so, while generative AI will fundamentally reshape product development economics, particularly in high-margin, innovation-centric industries.
Okay, that's a really clear picture of their distinct roles and trajectories. So for manufacturers listening right now, or maybe anyone looking to leverage these technologies in their field, what are the key strategic takeaways? What are the practical recommendations for navigating this over the next decade? Where should people begin?
Right, practical steps. I think the first and arguably most critical step, probably spanning the next year or two, say 2025, 2026, is to build a data-first foundation. This means really getting your data house in order. Unified data lakes or platforms, clean, reliable, time-aligned sensor streams from your equipment, well-organized CAD and CAE repositories. Both types of AI fundamentally need high-quality, accessible data to be effective, and getting this foundation right lowers the barrier to entry and experimentation significantly later on. You can't build AI on messy data.
Data first. Makes sense. Get the foundations right. What's next?
Then, probably for 2025, 2027, start with predictive AI pilots. Focus on areas like demand forecasting or perhaps remaining useful life prediction for critical assets. These generally offer quicker wins, they have clearer key performance indicators, KPIs, to track success, and they're often easier to govern and implement from a regulatory and transparency perspective. This builds internal confidence and practical capability with AI.
Okay, so lay the data groundwork, then get some immediate measurable gains and build experience with predictive. What about bringing in generative?
For generative AI, I'd suggest for maybe 2026, 2029, create a dedicated generative design hub or center of excellence. This would ideally be a cross-functional team, design engineers, AI specialists, maybe material scientists, manufacturing experts. It allows for focused exploration of high-value, perhaps initially low-volume use cases without disrupting core day-to-day operations immediately. It fosters innovation in a more controlled experimental environment.
A dedicated hub for generative exploration. Good idea. What about ongoing efforts?
Absolutely critical is to continuously invest in MLOps and model governance. MLOps is like DevOps, but for machine learning. It covers things like versioning your AI models, constantly monitoring their performance in production, detecting when their accuracy might drift over time, and having clear dashboards, maybe incorporating explainable AI tools. Predictive models need rock-solid reliability and trustworthiness. Generative models need safeguards against potential issues like hallucination, making things up, or generating biased or unintended outputs. Strong governance is key for both. And alongside that, develop talent pipelines. Starting now, really, 2025, 2028. Skill shortages are consistently cited as a major bottleneck for adopting both AI types effectively. This means training, hiring, maybe partnering.
Right, the infrastructure and the people. And that synergy we talked about, that secret weapon, how do we actively foster that integration between the two types of AI?
Crucially, yes. Looking towards 2027, 2032, the goal should be to actively leverage generative to predictive synergy. Use synthetic data generated by generative models to augment scarce labeled datasets used for training predictive models. And conversely, use the outputs or constraints from predictive models, like predictive performance or cost, to actively steer and refine the generative design process. This integrated approach maximizes the ROI from both types of AI and truly accelerates the innovation cycles across the entire product lifecycle. And one last point, monitor regulatory evolution constantly. This is critical, especially for AI-generated parts or designs used in safety-critical applications. Think medical implants, automotive safety systems, aerospace components. Staying ahead of the curve on compliance requirements and standards will significantly reduce time to market later and, importantly, helps build public and customer trust in these powerful new technologies.
That's a very clear roadmap. The Outlook summary you shared seems to map this out nicely too. Predictive AI becomes pretty mainstream from 2025, 2027, driving that widespread efficiency. Then generative AI really emerges more strongly from 2026, 2028, with those early adopters seeing significant cuts in design time and developing totally new product capabilities. And then we see this convergence phase, maybe 2028, 2030, where commercial platforms start offering integrated design, predict, optimize capabilities almost as a seamless service, leading towards 2030, 2035, where we're talking about real scale out and democratization, generative AI possibly moving into faster moving consumer goods design, and predictive AI maybe driving fully autonomous, self-optimizing factories. The vision of, say, 70% of global manufacturing sites running at least one autonomous predictive loop, that's quite something. Wow, what an incredible deep dive into these dual powerhouses of generative and predictive AI. It seems really clear that predictive AI is set to be the steadfast workhorse of manufacturing, certainly over the next decade, delivering those continuous, measurable efficiency gains across almost every operation.
Absolutely. And generative AI will be the strategic disruptor, the catalyst for innovation. Its biggest impact initially will likely be felt in areas like product development, material discovery, and perhaps high-value custom manufacturing, where the huge economic upside of faster, cheaper, better innovation outweighs some of the current challenges around interpretability and regulation.
So they really aren't competitors at all, are they? They're complementary pillars. Pillars of a future AI-driven, designed to deliver a value chain that looks set to define industries by, say, 2035. So for you listening, as we wrap up this deep dive, maybe consider this provocative thought. In your own work, or even just in your daily life, where might you be seeing opportunities right now for predictive insights? Where could they bring immediate, measurable efficiency? Or perhaps, where could generative creation entirely rethink what's possible? Where could it push the boundaries of what you currently assume is achievable? How might really understanding this fundamental distinction between predicting and creating empower you to navigate and maybe even help shape the AI-powered future that's clearly unfolding around us? Thank you so much for joining us on the deep dive. We really hope this has given you a useful shortcut to being well-informed on this important topic. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.